Hello everyone, in this video tutorial we will see how we can create vehicles intensity heat map or retail store heat maps using YOLOv7. We will also do vehicles counting using YOLOv7 and DeepSORT object tracking. We will count the number of vehicles entering and leaving. Okay, so here in the front of you is the output video of a vehicle intensity heat map with the vehicles count, the number of vehicles entering and leaving is presented. So let me just play this output video and show you how our output will look like. So you can see in the top left corner, we have the count of vehicles leaving, and the top right corner, we have the count of number of vehicles entering. So let's move towards the code part and see how we will implement this complete project. Okay, so here is the CodeLab file in front of you, which you can see over here. So for this project, I will be using this YOLOv7 with DeepSORT object tracking GitHub repo. So if you go over here, we have the Google Colab file link over here. So you can just click over here, open link in new tab. By clicking on this, you will the Colab file will open in front of you. So I have this Colab file open in front of me. So I will be using this Colab file for this project. I have made some few changes into the original Colab file, which is provided over here as per this project. So let's get started. In the first step, I am just cloning this GitHub repo over here, which is YOLOv7 DeepSORT object tracking repo. I am just cloning this GitHub repo into my Google Colab notebook. Okay, so I will go through all these steps once. Let me first explain you the vehicle intensity heat map code and the vehicles counting code. Then we will come back over here. Okay, so if you go over here, I'm just going to this GitHub repo and just open the heatmaps.py. So this is not in the official GitHub repo of YOLOv7 DeepSORT object tracking. I have made this heatmaps.py file as per this project for the vehicle intensity heat map. Okay. So let me explain you the key concept for the vehicle intensity heat map. Okay. So first of all, what we do over here is that let me just go below and explain you these things. Okay. In the first step, I am simply creating a numpy array where the value of all the numpy array is set to 1. So I am just creating a numpy array of ones by using np.ones. So it will create a numpy array where all the values are set to 1, and the size or the shape of the numpy array is the height and width of the current frame. So I have the input as the I have a in the input I have a video. So each of the video, the complete video is processed frame by frame. So it will process the complete video frame by frame, and it will have the height and the width of the current frame. Okay, so the shape of my numpy ones array, so numpy array of all ones will be the height and width of the current frame. H represents the height, W represents the width. Okay, so np.1. So if you look over here, so using this, our output will look like this. So we have a numpy array, okay, over here, and thus you can see it is filled with complete ones. Once we have only one value because we are creating the numpy array using np.ones. All the values will be 1, and the size of the numpy array is the height and width of the current frame. So the height and width we have for the current frame is the size of our or the shape of our numpy array. Okay, so in the first step, we are creating a numpy array of ones over here. You can see over here. Okay, so in the next step, what we do over here, let me just go above and explain you the rest of the code. Okay, so here the numpy array which we have created, we are just calling this numpy array because you can see that below the numpy ones array is saved in the variable global image np-array. So we are just using this variable over here, global image np-array over here. So if we see the output at this point, we can see that, okay, sorry. So if we see that here we have this form of output, like we have a numpy array of all the ones, and the shape is the height and width of the, basically in the shape of this numpy of ones array is the height and width of the current frame. Okay, so here we have this np.ones array over here, we can see over here, and now we are doing the increment of the frequency pointer for the whole bounding box. Okay, So basically, now what the next step, what we do, where we have the bounding box in the frame, there we increment the frequency counter. For example, in this specific area of the frame, we have this bounding box. So here you can see that we are incrementing the frequency counter, like all the other values are one, where we don't have the bounding box, and only at this place we have the bounding box. So here we have the value 22222. Okay, what is this basically? For example, if the in the video over here, you can see that at this place, if we have the bounding box over here, okay, if we have the bounding box over here in the image, then you can say that we have the we will do the increment of the frequency counter where we have the bounding box. Okay, so 2222 means here we have the bounding box and we are doing the increase in the frequency counter. Okay. Then we do the heat map array processing. So we are just pre-processing the heat map array over here. Okay, so and then we are applying the Gaussian blur over here. So if you write the Gaussian blur, it will do a it will blur the image. So if I just try to and show you the about the Gaussian blur. Okay, so if we just go to over here, I think Geeks for Greeks are the best example which I've seen. Okay, so here you can see that I have just applied a Gaussian blur, and here I've just set the kernel 5 by 5. So you can change the kernel size as per your requirements over as per your requirements. So you can see that after Gaussian blurring, so this is the kind of image like in the original image, this is our original image. You can see over here, and after doing the Gaussian blurring, we have this form of image. Okay, so here we have applied the Gaussian blur over here, and I have set the kernel size 9 cross 9, and here we apply the color map. So I have just set the color map as jet, but you can see I set the color map as rainbow as well. So let me show you how this works. Let me just copy this and show you what other color maps are available in opencv. So here I've just select the color map as jet. So you can select the color map as rainbow, winter, autumn. So you can select the color maps as per your requirements over here. And then I'm just overlaying the heat map image. So this is my heat map image onto my original image. Okay, so here I'm just passing, this is my original image. IM0 represent the original image, and heat map, this is heat map image represent the heat map images on which I have applied the intensity heat map. Okay, and I'm just setting the size of any means both weight as 0.5 and 0.5. So I'm just setting the equal weights for both the images. Basically in in the video we process the complete video frame by frame. So I'm just talking about the current frame as the image. So here I'm just passing the heat map image, and here this is my original frame or the original image, and the weight of each of the you can say the frame is same like 0.5 and 0.5. And this is my overlay heat map image, like output final image, superimposed image, and I am using this superimposed image in my output. So in the output you see this basically as of your output image. Okay, so here what I do is basically this is my heat map image, so I overlay heat map image on the my video frames over here. Okay, so this is my original image or the current frame, so I overlay the heat map images on the video frame or the all the frames over here, and the size of the weight, or you can say weight ratio, is set to be equal 0.5 0.5 over here, and this is the output image or output of the current frame, and we then just display this output video which you see on your screens. Okay, so I will show you this output as well. So first of all, let's see. So in the first step, what we will do, if we go over above, we are just cloning the GitHub repo. So just let me disconnect the runtime because I have already done this script. So let me just disconnect and let's start the runtime again. Okay. Okay, that's good. So first of all, I will clone this GitHub repo over here. This is the YOLOv7 DeepSORT object tracking repo. And then I'm just setting this repo as my current directory over here. So then I will install all the requirements. So it will install all the required libraries necessary to run this project. So if any of the library is missing, then you might face the error that the following library is not installed if you run the training or the validation script. So it's always better to install all the requirements, which will install all the required libraries. So now to display the output image or the output video into the Google Colab notebook, I'm just creating a virtual screen over here. Then to implement the object tracking, I'm using DeepSORT to implement the object tracking. So we need DeepSORT files over here. So using object tracking, we assign a unique ID to each of the detected objects. So this is the use of object tracking. Basically, through object tracking, we assign a unique ID to each of the detected object. And we are just downloading a sample video to test our model from Google Drive. And here we have the files from the Google Colab notebook. We are just downloading a heatmaps.py file. I have placed this updated file into my Google Drive. So I'm just downloading this file from the Google Drive into my Google Colab notebook. Okay. So just seeing this is my present working directory. And now let's run this script. Okay, so I'm just testing YOLOv7. I'm taking the pre-trained model. You can take any custom model as well. I'm just running the heatmaps.py script on the test1.mp4 video. So this might take some time for the execution, so let's wait. And as it gets complete, then I will show you the output video and see what results do we get. So as it starts, I will just pause the video, and when it is complete, I will show you the output video, and then we will see what results we are getting. So it has divided the complete video into 942 frames. So this might take some time. So let me get back as it completes, and then we will see the results. So guys, the processing on the video is done, and here we have the output video over here. So let me just download this video and see what results do we get. Okay, so the video is downloaded. Let me just shift my screen towards this video and show you the results over here. Okay, so now you on the screen, you can see the results. So now you can see that as the traffic on this side is more, so you can see that we can see the traffic intensity heat maps or the vehicles intensity heat maps over here. So you can see that as on this left side, the traffic is very much high. So we can clearly see the vehicle intensity heat maps in over here. So that's very good. While on the right side, the traffic is very low. So we can't see that vehicles intensity heat maps, but on the left side, there is a huge traffic. So we can see the vehicles intensity heat maps clearly over here. I have already tested this model on demo video as well, to demo video 2 as well. So here is the output video. I have already run the script heatmaps.py script on the video. So here is the output video, and let me show you the results. Let me download this and just play this video, and let me show you the results, what results we are getting over here. So in front of you, you can see the output video being played, and you can see that in this place only the 4 people have gathered over here. So you can see that where we have the intensity heat map, while on all the other place we have 1, 2 people standing at a time. So you can see that on all the other places we don't have the intensity of the crowd, very much intensity of the crowd, while on this place you can see that the 4 people are standing together. So you can see a intensity heat map over here, while all the other place we don't have very much gathering, so we can't see the intensity heat map. So let's go back towards the code and see some further things. So I have already explained this key concept to you. So let's see how we can integrate the vehicle counting in this script as well. So I have already integrated the vehicle counting as well. So let me download the updated heatmaps.py file and explain you the complete code. Okay, but before explaining the code, so let me show you what kind of output we can expect. So let me download this output video. I've already done this script on the video, and let me show you what kind of output we should expect after running the vehicle counting. Okay. So if I share my screen, so this is the kind of output we should expect. You can see that one thing, when this vehicle trails crosses this line, like this line you can see over here, when the vehicle trails crosses this line over here, we can say that we have the count, like when the vehicles are moving in the north direction over here, we can say that the vehicles are entering, and when the vehicles are moving in the south direction over here, like on this direction, we can say that the vehicles are leaving. Okay, so when the vehicles in these trails, this line intersect with this line, we can have the vehicles entering count increase, and when this trail intersect with this line, we have the vehicles leaving count increase over here. Okay, so this is all which we are doing over here, and using object tracking, we are assigning a unique ID, which you can see 11 over here, and this is the object name, the detected object name truck over here. And here we have the unique ID 21 of bus over here, and you can see the object name over here. So this is to all which we are doing. So let me explain you the complete code, and then we can further explore the things over here. So if I open the heatmaps.py file over here, this is the updated heatmaps file which I have downloaded. Okay, so I will explain you the complete code, so you don't need to worry at all. So, okay, so here we have the complete code. That's fine. Good. Okay. So first of all, what we need to do is, if we go over here, here I'm just importing the DeepSORT modules for the object tracking purpose. Okay. And then we have created a count up and count down. So let me open this in the paint section, and let me explain this from. So guys, in front of you, you can see the image. If you can see the image now, okay. So now you can see that we have created this green line manually as well. Like you can see this green line over here. We have created this green line manually. So one thing is that when the vehicles trails, these are the trails of the vehicles over here, the thick line. Okay, when these trails intersect with this line over here, we have the count, the number of vehicles entering. Okay. And when these trails intersect with this line over here, we have the count, the number of vehicles leaving. Okay. So here we can see the total count as well, and the count of the individual vehicles like car 7 and bus 1, and the total count is 8. And here the car 15, the trucks 4, and the total count is 19. Okay. And here you can see the intensity heat map over here, as there are more traffic on this side of the road. So we can see the intensity heat map over here, while there is a very less traffic over here. So we can't see the intensity heat map over here. Okay. So one thing you can have noticed that we have not created a bounding box around the detected object. We can also create it by, if you just need to write the cv2.rectangle. I will show you after this as well. We will add the bounding box as there as well. Plus, you can see that each detected object is being assigned a unique ID using DeepSORT object tracking. And here we have the object name. Okay. So here you can see that the detected object is assigned a unique ID 60, and here we have the object name. So this happens with all the objects over here. Okay, so let's go back towards the code part and explain you the rest of the code. So here we have defined the count up and count down. So count up will have the total count, and the count down will have the total count of the vehicles leaving, and count up will have the total count of the vehicles entering. Okay. So in the count up, we have the total count of the vehicles entering. In the countdown, we have the total count of the vehicles leaving. Plus, you can see that if the vehicles are moving in this north direction, over here, we can say that the vehicles are entering, and if the vehicles are moving in this direction, the south direction, we can say the vehicles are leaving. Okay. So further thing, if we go back towards the code over here, here we are just converting the output for received from the YOLOv7 model into a format that is compatible with YOLO DeepSORT object tracking. Okay, so in this version, we are just representing the output of the bounding box coordinate received from the YOLOv7 to a format that is compatible with a DeepSORT object tracking over here. And here we are just assigning the colors to each of the detected object. And here we have the UI dash box function. So currently you have cannot see the bounding boxes around the detected object. So here I've added a cv2.rectangle so that you can see the bounding boxes around the detected object over here. And here we have created an intersect and CCW function. So the intersect function is used when the two line segment intersect. Let me just show you the image. Just give me a minute. I think I have saved this image. Okay, just give me a second. So let me find it into my folder. Okay, I've just found it. Okay, so let me just share my screen towards this image. So now you can see the this image over here. So to represent the intersection of two line segments. So for example, here we have these two lines, one line and the second line. So in Python to represent this intersection, we have this formula defined intersect, and CCW is being called in this formula over here. Okay, so what here we are doing is that where we are finding the intersection, let me show you. So now you can see the image. Basically, when these trails line intersect with this green line, then we have the count. Or you can say that when this trails line, you can see this trail line, yellow line over here, when this intersect with this line, then we have the count of the number of vehicles entering. And when these trails line intersect, we have this line, we have the count of number of vehicles leaving. So here we are just finding the intersection, and I have shown you the formula for the intersection over here, which you can see. Okay, so we are just adding this Python code into our, I think I've just opened the, okay, just give me a minute. So in Python, to represent the two lines intersection, like these two lines, we have this Python, or you can say we have this Python code. So we are just using this Python code currently as well. So let me go back towards my code part over here. So now you can see that we are using this intersect and CCW to find the intersection between two lines over here. And here we are finding the direction. If the vehicles in moving in the north direction, we have say that the vehicles are entering and the vehicles are moving in the south direction. We can say that the vehicles are leaving, and we are not focusing on the east and west direction currently. Okay, so in the draw dash boxes function, we are creating a bounding boxes around the detected object. Okay, so now you can see that in the south, we can saying that the vehicles are leaving. In the north direction, we have the vehicles entering, and we are storing the object entering and leaving count in the object counter one dictionary, which we have created over here. So in the object counter one dictionary, we are storing the vehicles entering count, and in the object counter dictionary we are storing the vehicles leaving count. Okay, so in the dictionary what we do in the dictionary, we have a in the dictionary we have a key and value. So in the key we have, for example, car and the count like 6 cars and enter. In the other key can be truck and the count that 7 cars have entered. Okay, okay, in that, and that other key can be truck, and we can say that 7 trucks have entered. So this is all we are doing, and then we are just setting the UI, how we should want to display this text in the UI over here, on our screen over here. We are just setting the UI over here using this cv.output text, and then we just run the script and get the output. Okay, so let me just run this script and show you what kind of output do we get. So let me just run this script on some other demo video and show you what results we are getting. So I'm just downloading the demo video, and just let me run this script. So this might take some time, so let's wait until the scripts run successfully. And at it starts, I will just pause the video and show you when we get the output from here. Okay, so this might take some minutes or few time, but let's bear with me. So the script has started, so it will take some time. So as the script runs successfully, I will be back and show you the output. So the processing on the video is done, and here we have the output video, which you can see over here. Let me download this video and show you what output do we get. So just downloading the video, and let me play this video. So just navigating my screen towards the video. Okay, and then, okay, so here you can see the output video on your screen. So you can see that we have the bounding boxes around the detected objects as well. We have the count of vehicles leaving, the total count, the cars, truck, and we have also have the count of vehicles entering, the total count, and the separate count like 31 cars and the 5 truck. So the vehicles moving in this north direction are the vehicles entering, and the vehicles moving in this south direction are the vehicles leaving. And here we have created a manual line by ourselves, which you can see over here. So then when the vehicle crosses this line, we can say that the vehicles are leaving if the vehicle crosses the line from here. And if the vehicles crosses the line from here, we can say that the vehicles are entering. So this is all from this video tutorial. I hope you have learned from this video tutorial. See you all in the next video tutorial. Till then, bye bye.